Have you ever wondered how data was stored and managed before modern database systems? In the early days of computing, long before the advent of cloud storage and sophisticated databases, data was stored in a much simpler, albeit less efficient way. This was the era of traditional file-based systems. Picture this. Rather than sleek servers humming in a climate-controlled room, data was stored on physical media such as hard drives, magnetic tapes, or floppy disks. These traditional file-based systems were the pioneers in data storage and management. They were the precursors to the modern systems we use today, and they laid the groundwork for how we think about and interact with data. In these systems, data was organized into files, with each file corresponding to a specific application or data entity. The files were stored hierarchically in directories or folders, forming a file system structure. However, these systems were not without their challenges. They lacked data independence, meaning that applications interacted directly with files and managed their own data. There was no separation between the logical structure of data and its physical storage. This close tie between applications and their data led to data dependencies, making it difficult to modify applications or data structures without affecting other parts of the system. Sharing data between different applications was also a significant challenge. Since each application managed its own data files, sharing data required implementing custom file handling mechanisms, which could be complex and prone to errors. Despite these challenges, traditional file-based systems were an integral part of the evolution of data storage and management. They represented the first steps in a journey that has brought us to where we are today, with powerful databases and flexible cloud storage solutions. So, traditional file-based systems were the first step in our journey to manage and store data efficiently. They may seem primitive by today's standards, but they were a critical stepping stone on the path to the sophisticated systems we use today. In the next scene, we'll delve deeper into the characteristics of these systems and explore how they shape the future of data storage. Now let's dive deeper into the characteristics of these traditional file-based systems. At the heart of these systems is a file-centric organization. Data is neatly organized into files, with each file typically corresponding to a specific application or data entity. These files are stored hierarchically in directories or folders, creating the structure of the file system. It's like a digital filing cabinet, where each drawer is a directory and each file is a document within the drawer. But here's the catch. There's no data independence. The applications interact directly with the files and manage their own data. There's no separation between the logical structure of the data and its physical storage. This lack of independence creates data dependencies and makes it challenging to modify applications or data structures without affecting other parts of the system. It's like trying to move a document from one drawer to another without disturbing the other documents. Not as easy as it sounds. Then comes the issue of limited data sharing. Sharing data among different applications is often a challenge in traditional file-based systems. Since each application manages its own data files, sharing data requires implementing custom file handling mechanisms. And trust me, that can be complex and error-prone, a bit like passing a message in a game of Chinese whispers. Data redundancy is another characteristic of these systems. The same data may be duplicated across multiple files or stored in different formats by different applications. It's like having multiple copies of the same document in different drawers of the filing cabinet. Confusing and inefficient. Data inconsistency is also a common issue. With the lack of centralized control and data dependencies, ensuring data consistency and integrity can be difficult. Updates and modifications to data must be carefully managed to avoid inconsistencies. It's like trying to update all copies of a document simultaneously, a tough task to manage. Another limitation is the lack of robust mechanisms for managing concurrent access to data by multiple users or applications. Without proper concurrency control, issues such as data corruption, lost updates, or data contention can occur. It's like having multiple people trying to edit the same document at the same time. Chaos. Finally, we have limited security and access control. Security features in traditional file-based systems are typically basic. Access control mechanisms are often based on file permissions and are limited in granularity and flexibility. It's like having a simple lock on the filing cabinet. It provides some security, but it's not foolproof. These characteristics, while functional for their time, showcase the need for more efficient systems. But remember, It's not about criticizing the past, but understanding it, as this understanding paves the way for the evolution of data storage and management. The limitations of traditional file-based systems sparked the development of more sophisticated database management systems and file systems that we use today. These modern systems offer features such as data independence, transaction management, data integrity, concurrency control, and robust security mechanisms, a huge leap from the traditional file-based systems. But that's a story for another time. The limitations of these traditional systems soon became apparent as the complexity and volume of data increased. Imagine you're working in an office and you've got a file cabinet stuffed with paper files. Each application in your computer system has its own drawer where it stores its data. Now, another application needs some of that data. It's like having to manually search through the file cabinet, pull out the right file, and copy the information. This is what data sharing was like in traditional file-based systems: complex, time-consuming, and prone to errors. What's more, because each application had its own file, the same piece of data could be duplicated in multiple files. This is known as data redundancy. Say you've got a customer's address stored in 3 different files. If that customer moves and you update the address in one file but forget the others, you've got inconsistent data. And in a world where data is king, inconsistency can be a real headache. Then there's the issue of concurrency control. Imagine 2 people trying to update the same file at the same time. Without a system in place to manage this, you could end up with data corruption, lost updates, or contention. Traditional file-based systems often lack the mechanisms to handle this, making it a real challenge for multiple users or applications accessing the data simultaneously. And let's not forget about security. In a traditional file-based system, access control was often limited to file permissions. It's like having a lock on the file cabinet but not on individual drawers or files. This lack of granularity and flexibility left these systems vulnerable. In a nutshell, whilst traditional file-based systems served as the groundwork for early data management, they struggled to cope with increasing data complexity and volume. They were plagued with issues such as data redundancy, inconsistency, limited concurrency control, and rudimentary security. These challenges triggered the evolution of data storage and management systems. As the saying goes, necessity is the mother of invention. And in this case, the need to overcome these limitations led to the development of modern database management systems and file systems. But that's a story for another time. As technology advanced, so did the need for more sophisticated data management systems. The transition from traditional file-based systems to modern database management systems and file systems was a necessary evolution, spurred by the increasing complexity and scalability requirements of the digital age. Let's take a closer look at this transition. Traditional file-based systems, while fundamental in the early days of computing, were soon outpaced by the escalating demands of modern applications. Their limitations, such as lack of data independence, limited data sharing, data redundancy, and data inconsistency, were hurdles too high to ignore. The need for a more robust, flexible, and efficient method of data management became glaringly apparent. Enter modern database management systems and file systems. These advanced systems address the shortcomings of their predecessors head-on, revolutionizing the way we store and manage data. They brought in the concept of data independence, creating a separation between the logical structure of data and its physical storage. This meant that changes in the data structure wouldn't affect the applications using them, a massive leap forward. Modern systems also championed data sharing. No longer did each application need to manage its own data files with custom file handling mechanisms. Instead, data could be shared and accessed across different applications, streamlining operations and reducing errors. Data redundancy and inconsistency, 2 significant pain points of traditional systems, were also tackled. Modern systems minimized data duplication and ensured data consistency and integrity through centralized control. Updates and modifications became a manageable task, eliminating the risk of inconsistencies. And let's not forget about concurrency control. Modern systems introduced robust mechanisms to manage concurrent access to data by multiple users or applications, preventing issues like data corruption, lost updates, or data contention. Last but not least, security and access control. The rudimentary security features of the traditional systems were replaced with comprehensive, flexible, and granular access control mechanisms, protecting our precious data like never before. Modern systems have come a long way from their traditional counterparts, offering more efficiency and reliability. Indeed, they have transformed the landscape of data management, providing us with the tools we need to navigate the ever-evolving digital world. So, the journey from traditional file-based systems to modern database systems has been a fascinating one. We've traced the evolution of data storage from its early days, where data was organized directly into files on the computer's storage media. We've looked at the key characteristics of traditional file-based systems, such as their file-centric organization, lack of data independence, and the complexity of data sharing. We've also addressed the challenges these systems presented, like data redundancy, inconsistency, and limited concurrency control. Security and access control were also rudimentary, often leaving much to be desired. And then, we saw the shift to modern systems, spurred by these limitations. Modern database management systems and file systems have largely replaced traditional ones, offering features like data independence, transaction management, data integrity, and robust security mechanisms, meeting the complexity and scalability requirements of today's applications. This evolution shows how necessity indeed is the mother of invention. Until next time, keep exploring the fascinating world of data storage and management.